This is Woodworth. I'm with the Orbiter program. I'm the chief engineer for Orbiter Element. Within the shuttle program itself, we've had parts that were built by various vendors. Each vendor uses their own unique hardware, uses their own unique specifications. And with that, once you end up with a completed orbiter, we have to have multiple people with multiple critical skills. Engineers have to keep track of multiple specifications in order to work the orbiter. The orbiter is just one part of it. Then you go into the whole shuttle program. So now you got your solid rocket boosters. They work to unique specifications, have unique hardware. External tanks the same way. And then not only that, but you go across to different programs. The station has completely unique hardware. For example, soldering. Soldering is very common. It's used across all elements, all programs. But each vendor may have a unique set of specifications they use, unique practices they use. So then when it comes down to the end user, you have to keep track of all these specifications, have to keep track of all these unique pieces of hardware that are used. Fasteners. Fasteners are used to assemble all pieces and parts. In our case here, we've got parts that are pieces that have been made by vendors across the country, and each one has come up with a unique set of fasteners. So logistics has to keep track of all these different fasteners, all the different drive tools in order to use them. If there's ever a discrepancy, you're looking to go back to get this unique fastener again, or trying to substitute another fastener. The thing about having unique specifications, unique materials, unique processes is that it requires more logistics in order to keep track of this. It requires more engineering effort, keep track of the specifications, to understand the specifications, to interpret the specifications, to apply the specifications. For the technicians, it's more critical skills that they have to understand. There's potential for process escapes or process errors using one application in the wrong situations. In other words, using a specification for one vendor and an application for another vendor. So it promotes the opportunity for errors. Commonality will eliminate a lot of that. This is Woodworth. I'm with the Orbiter program. I'm the chief engineer for Orbiter Element. One thing that drives cost is having a unique design, having unique hardware, unique specifications, multiple specifications, unique materials. All this drives cost and it drives schedule. And so the thing to strive for is commonality. Commonality is something that would be good to use within a program, but not only that, across programs. We should be establishing standards that are imposed on our vendors. In other words, we should be using standard aerospace or commercial specifications, not vendor unique specifications. We should use federal qualified parts lists as opposed to qualified source lists. In other words, a vendor will come up with their own unique hardware, their own unique specification, and impose that on the program as opposed to the program stating right front, these are the specifications we're going to use. These are the this is the hardware that we're going to use, and imposing that onto the vendors. An example of commonality is within the design too. There may be cases that flex hoses that you may have multiple uses for flex hoses, but rather than having a specific design, diameter, length for each unique application, if it's possible to come up with one style of flex hose, one diameter, one length, and incorporate that into all your designs. Therefore, logistics only has to track and purchase one standard, and that's something that can be used within one program, and it should be something that's used across the program. This also allows shared learning. One program may go off and find they have a problem. This is something they can share and benefit and pass the results on to another program. One program comes up with a unique or an improved process. It's something that can easily be shared to the next program. The goal is to strive for commonality, but there are obviously going to be situations in which you may have a unique situation where unique hardware has to be designed, and that's understandable. In other words, you may have an area where you have some extreme temperatures where the common fastener or the common thermal protections you would look to use may not necessarily apply. In those situations, you have to design for your proper aspect. But if you can minimize those and reduce those, obviously it's something that can reduce your cost. If you look at every application and provide a unique installation, in other words, a unique hardware, unique thermal protection, then you can see where you would escalate your cost.